Hello everyone. In this video tutorial, I'm going to show you how to design a complete steel structure in Midas Gen. In previous tutorial, we have discussed very simple models. So in this time, we want to create a multi-story structure, uh, steel structure in Midas Gen. So we go through to the modeling. We can create a new file or new project. Here we have three options to create such a structure. Even you can bring from DXF file plan of that structure, and then you can create elements, or you can create nodes, and this will be very traditional method, and also but in some specific structure that's good. So what I want to do is I want to go into the structure, basic structure here, and I create a frame. In the frame, I want to that in the x direction is a 3 bay, which each bay has 6 meter to length. The repeated is 3, which is called 3 bay, and this is the height of the structure. So each height is 3.6 meter, and the total is 5 stories. Now I can go to add x code and I add z code. Now here is the structure. One frame is created, and next going to the edit. In the edit, I want to select this one here, and I want to add the material. We're using this time the European code and using steel 335. And so OK, and the second using same for the section using HB 300 and HB HB 400. Now we have two sections. 300 is for column and 400 is for beam. Now close this, and we don't want to apply any slab, so just let's do section properties is okay. Now here is I want to create generate frame, and this is the frame generated, but the section is taking for all 300. So later I can change to delete that section. And also here is the element. I also can here delete the element. So now this is the first element. You can go to this element, and you can this element. I can quickly delete this element, and here also delete. So this bottom is no need. Now I'm going to apply, and it's created. One thing I can quickly go to here, select the beam, so I want to change the beam section to 40. Here is the section, and this is section. Just drag, and it automatically changed. Now we want to select all, and here is the element, and I want to go to translate. Translate, I want to select the entire structure, translate in here is giving the distance. So this direction is y. If I go to a little zoom, now you can see this is y direction, and I'm going to give y direction is about 5 meter. 5 meter in a y direction. The repeat of the time is the same with x direction. I'm going to apply, and you see it's 3 other frame is created. Now what I want to do is I want to go to the one of the views. I can select just nodes, even the frame also well selected, so it's okay, just one is okay. uh, Now I can go to the element, and this time I want to extrude. So I want to extrude. It requires me to save. I'm going to call Midas frame. Sorry. Uh, Extrude this. This is node to element. So this is the column. I'm going to using 14, and it's in a y direction by 5 meter, 0, and how many repeats? So equal to 3 base. Apply, and you can see we automatically created a structure in a few seconds. Now we go to the next. This is finished. We go to the boundary condition. In the boundary condition, first of all, I want to select the bottom of the structure. Use select by plane, and I select x y giving 0, and I'm going to select apply, and all the boundary in the bottom of the node is selected. Now what I want to do is I want to define boundary condition, and I want to consider fix in all direction. So the next I want to define loads. We have a dead load, which is including the self load and live load, which is the floor load, and also ex the seismic load. In even I can consider one direction because yeah, two direction, because one direction is more steep, one direction is less, x, and also adding y. Now the first, go to the load. Here is the load, and first I want to apply the self load in a -z direction. Going to add the second other load, a live load and dead load of the floor, is going to apply here. Going to assign floor load, but before that I should create some type of load. Let's call it roof, LL plus dead load. Here in a class I should select dead load in the first one, dead load, which is total dead load. Extra dead load is -2 kilonewton, and live load is -4 kilonewton. Now we added already, and I'm going to OK, close, and here we got that roof dead load, live load. And so what I want to do is I'm going to the one of the direction, and here I want to select this floor, and here is the command is called active. Just it will show the selected active file. Now actually in this slab is two-way slab. Now I want to use the two-way, and you also have another option in case it's one way, you also apply. Now here is defining load area, and it's called me copy floor load to the upper load. So the distance from one is 3.4, and here is actually wanting z copy or populate to the upper stories. Now I want 4 more stories at 3.4. Now I can go to select node here, here, here. Now you can see all the load is applied in the floor. Then it automatically changed to the beams, and this is a little better or good option from Midas Gen. Now we finished, and I can go to right click, and here called active all, activity is called active all, and all the structure is added. So now you can see the load is applied into entire structure. So now this load is finished, and we want to define uh, the first one was created in the okay, that just date load live load is okay. We can go to in the live load we didn't define, but in the date load we have one flow load. In the first load case, I should say that flow load case. Now I can, in case if I want to uh, properties, and I can delete that live load. But instead of this one, I can call it date plus live load. Now this is self load, and also this is flow load, because this flow load is including the date load and live load. Load case EX, which is earthquake. In the load, I will go to the seismic load and define seismic load. So the seismic load, I want to use IPC code 2019, and here is the site class. So the DS is stiff soil. We want to use B, and this parameter, the short period of ground motion is 0.17, and this okay. When I give this one, this other automatically will calculate it. Now this is important factor is 1. I want to select this first one is for steel structure, okay, this one, okay. And one more thing I should say, this is a still moment resisting structure, so I'm going to give 8 and give this time period, and this is just in Y, and oh sorry, but before this I should go to here in the load. I should change loads to masses, because when we want to create a shear force, so the program automatically will calculate for us. So now I want to consider the load factor for date and live load 1. So okay, now we can go to back to again to load, and here is going to seismic load, create ex. The code is IBC to 10, and this is going to be 1. Let's make a little larger to get more shear force. And the risk category is 2, importing factor is 2, and approximate time using the first one for steel structure. Oh sorry, one more thing which is not creating is going to the story. Here we should create the stories, otherwise the structure will not generate force. So we want to okay, so we created this the force. The program will detect the height of the structure there. Going to load again, seismic load, and this time we will create again IPC 10, and let's give 1, and this is 4, and 1 factor, this is 8 for steel structure, you can check, and just it's in the X direction. Giving the time period is this one, okay, and it's calculated in the Y should be 0 now for the time being. And now we can see the force is created here. So the bottom, I'm going to force apply, and we go to the second one. Same criteria, same properties, but this one should be again, and this is 0, and this one be 0, this be 1. And I can go to see this load is giving in the Y direction. Okay, and we created 2 load. Now the load is also applied, and this is the center of mass. The next is going to the analysis. I'm going to perform analysis. Yeah, analysis so fast, in about 2 seconds completed, and now we want to go to the result. But before showing the result, we should create some combination. So we're going to auto-generate combination. We're using you can use lateral resisting force design, also allowable stress design. So I go to use allowable stress design still, and I can call some factor for seismic design you can consider, but just I will set this default, and I'm okay. Now we created let's see, this one is 0.1 and it's minus 50%, so we have another one. All this combination is giving this on the code. Now we can in the results we can see some let's see the reaction force, maximum XYZ, and I'm going to here you can see maximum, and here is giving the maximum minus 400, the moments also, and this is the X 231 132. So like this we can check another list the deformation from the EX, apply EX, this is it. And if I uncheck this, you can, or I want to see animation list with rendering, you're going to apply and you can start the animation. So this is the force which is created animation, and also we can see in the Y apply value. So the maximum is about in the node 91 about 100. Very it's actually meter because it's very small. We're gonna go to C millimeter and I'm going to apply again, and you can see here is about 40 millimeter, and it's about 40 millimeter and 0.8 millimeter. Even I can go to search node and I can go to see this point is dy is 12 millimeter, and this one also. Here you can see the deformation. Now we can also go to see the some stresses in beam column during the earthquake. Applying this one, you can see the contour. Here is large, here is large, and top is least, which is green. Now we can go to the design. In the design, we can select design code. So we want to use that ASD code. So we don't have any bracing, we check it, we didn't check the bracing. Go to again, and this time because just get familiar with the design of steel structure, I will not deal with each parameters. Just for simplicity, I will change the materials and also the design code. Here I'm going to call steel design, modify steel material. In previous I give A3515. In case if it's not available, you can change which steel you want. If I want to 275, and then just modify, and then again go to the steel design and call design check. We just click check, control number 6, and the design is starting. Now member is checked. The design time and also analysis time is quite fast and give you a very reliable result. So this is both is passed based on this loading criteria, and now we can check the member and you can see all member is giving. So the entire member is okay. You can just as example, I want to select this one and I want to connect showing the summary of that selected column, and here is the checking is passed, combination, the moments, share, everything, and finally it passed. Oh, one more thing, and I'm going to here select graphical, and it's better and a lot of information, including which checking we should consider. So the slenderness ratio is important. It's checked. The axial strength, so it's beam, which is no need axial strength, so it's become okay. Now the bending is so the measure bending is come from beam, so here it's checked okay in two kind of beam, in X, Y and Z. Also the tension plus bending check, and the shear strength also checked okay. Now the deflection check is, so the use this equation in case if you think that equation is not enough, you can change. So using this one is about 60 millimeter, so which is 0. Okay. And so this the final is in case if you are not satisfied with this, you can go to back to the design and still, and here is called optimal design. So it will start to optimize the proper section and material for you. Now it's finished, and you can instead of that, so this is optimal. In the optimal there is some technique. Let's select this one and select this 13, and then you can analyze option or column design, because that's column, so when you're using which force you want actual force including moments, so okay, and again it will start to design for you. It will create a different iteration, so then give you a proper result. Now just in analysis option you can actually give so number of repetition. So for one repetition this check is okay. So in case if you have 2, 3 or 5 section, then you can do for each one optimal design, and finally you can find a proper section. Now the last one is we can export this to as a DXF file, AutoCAD DXF file, and you can consider all things. Export DXF file, and so I want to open the DXF file quickly. And now here is the DXF file. And this is it. uh, so just I want to use visual style, and you can see now here is yes, if I go to the front, and you can see the beam column frames, and like this. If I select, this is here, which is center to center, in case if I want to bring it to back to here. So you can consider to uh, uh, consider to provide drafting or shopping in this, and also you can make scheduling as well. So and we need to design the connection, and so the connection also we can directly use here in the tool, use the design plus, or also it's quite uh, integrated with other software. Let's export with IDE Statica file, and also IFC file, and also Revit file. Revit file here is not. I think in the tool you can find, you should have a plugin, then you can set there and you can provide the connection design and as well as the shopping. So this is the end of the tutorial, and if you have any question, please put in the comment. I will find time to answer you. And next tutorial will be using response spectrum analysis, and also concrete structure, considering shear wall, and also basement, other structure. See you next time.